Continuing on with March 2012 Unit 2 paper, we're going to be looking at question 8 onwards. So on the grid, draw a graph of y equals 4x minus 2 for the values of x when x is minus 2 or 3. There are two ways you can tackle this question. The first way is with a table of values. So I'm going to put my x and my y. I'm going to pick all my x values mentioned here. So minus 2, minus 1, 0, 1, 2, 3. I'm then going to insert my value of x into the equation and then work out my value of y. So 4 lots of minus 2 is minus 8, minus another 2 is minus 10. If I continue to do this with the rest of the values. The next thing I need to do is plot each of these points onto the graph. Because there's no cubic function here, it's just a y equals mx plus c. When I plot these points on the graph, I should get a straight line. Here's one I prepared a bit earlier. All the points, minus 2, minus 10, minus 1, minus 6, all plotted. I then need to join up all the points to get my final third mark. So I just do a straight line going through all my points. To double check I've got the question right, it is a straight line that is formed. The second way to answer the question would be to use y equals mx plus c. The c part is my y-intercept, so I know it's going through the y-axis at minus 2. I can mark that on the graph. The gradient is my m part, which is, in this case, 4. So I know for every one along, it's going to go 4 up. For every one along, it's going to go 4 up. Again, I just need to join these points up and extend the line to get the third mark. This next question is asking me to draw the diagram of this front elevation and side elevation from the plan or the bird's eye view. So I need to think about how wide my plan view is going to be, and from the front I can see it's going to be 6 wide. I can also tell it's going to be 5 high, but that's not going to be viewed when I'm looking from above. Now looking at the side, I can see that it's going to be 4 deep. Again, I can see it's going to be 5 high, but that's not going to be viewed from above. Using these dimensions, 6 and 4, I can draw my rectangle, of course using a ruler. 6 wide and 4 deep. The next thing is to do a sketch of the prism. I need to bear in mind what I need it to look at like from the front and from the side. From this sketch here, you can see the side view looks like a trapezium, like in the side elevation. And the front view has a small rectangle followed by what would be a larger rectangle above. Again, the first thing to note on question 10 is that it's got a star next to it, so I need to include a couple of sentences to explain my working. So, a lot of people knew what the correct angles were here, but didn't use the correct mathematical reason to why. The first thing most people labelled on was this being 40 degrees. That is correct, but I then need to give a reason for that. ABE is equals 40 degrees as it is a vertically opposite angle. These two angles here are vertically opposite. I can mention that in a sentence, and if I want to, I could also maybe make a note of it on my diagram. My next one is I know that this is an isosceles triangle because two of the lengths are the same. So I know both of these angles are going to be the same. Again, I need to mention this. My two angles A equals B, as ABE is an isosceles triangle, or words to this effect. So there I'm doing 180 minus my 40, and then I'm dividing that by 2 to get 70 degrees. Again, this fact here is because the angles in a triangle equal 180. The next part to mention is that this angle has to be 40 degrees. I can do that by mentioning it's alternate to this angle, or that it's corresponding to this angle. My final thing to mention is angles on a straight line add up to 180. So x is going to be 180 minus 70 minus 40 to get my answer of x equaling 70. This is a 5-mark question. Just getting the answer x equals 70 gets me 3 marks. The other 2 marks come from giving 2 of any of these explanations. To be safe, write down your reasoning for each of the steps. Question 11 on indices. These should be some really easy marks for us to pick up on the Unit 2 paper. So, 5 to the power of 0. Anything to the power of 0 is 1. For example, 7 to the power of 0 would be 1, and 8 to the power of 0 would be 1. And guess what? 568 to the power of 0, also 1. Our next question, find the value of 27 to a third. Because it's to the power of a third, whatever's on the bottom of the fraction is which root I am finding. So, 27 to the third, I'm finding the third root of 27. As 3 times 3 times 3 gets me 27, the cube root of 27 is 3. In this next example, 81 to the power of a half, I'm looking for the second root, or square root. The square root of 81 is 9. In this next answer, 2 to the power of minus 3, the minus means I become 1 over whatever's left. So, it's going to become 1 over 2 to the power of 3, or 2 cubed. This becomes 1 over 8. It's key to mention that none of my answers from my indices should be getting out negative answers. The negative simply means that it's the reciprocal, or 1 over that 2 to the power of 3. We're going to combine the next two in just a further example. 36 to the power of minus a half. I'm going to do the minus part first, so it means it's going to be 1 over 36 to the half. Because it's a half, I'm going to be looking for the second root of 36, or squared root. So 1 over 36, square root of 36 equals 1 over 6. Question 12, which is a 3-mark question. I've highlighted some of the key points. PT and SPS are tangents, and the angle TPO is 24. The first thing to do is know from my circle theorems that the tangents meet a radius at 90 degrees. Labelling these as 90 degrees picks up 1 of your 3 marks. The next thing is angle TPO is 24. To work out which angle that is, I go from T to P to O, and it's the angle in between those lines, which I then label as 24. That enables me to label the bigger angle here as 48, and left in this kite is a quadrilateral where I know 3 of the angles. In a quadrilateral, the interior angles add up to 360. So 360, take away 90, take away 90, take away my 48, gets me 132. Question 13. To view this question, we've also got a star next to it, so I need to use some mathematical language, or at least include one sort of sentence in your answer. The sentence I'm going to use is going to be how I tackle this question to start with. I need to work out the area of the shaded section. So what I'm going to do is do the area of the rectangle, take away the area of the triangle. Some people, I saw very nicely in their diagrams, label some of these. So this was A, maybe this was B, and they labelled that as A and the big rectangle as B. The next thing to do is work out each side. So the rectangle is going to be x plus 6 times my 3x minus 5. Again, using any method to expand double brackets, I've chosen to use FOIL here to get my 3x squared, my plus 18x, my minus 5x, and my minus 30. In my triangle, I've got 2x times my 3x minus 5, and because it's a triangle, I'm going to halve my answer. This works out to be 6x squared minus 10x divided by 2, which gets me 3x squared minus 5. I'm then going to input these back into how I was going to work out the shaded part of my shape. 3x squared plus 18x minus 5x minus 30, take away 3x squared, take minus 5x. The 3x squared and the minus 5x's cancel out, leaving me with the 18x minus 30. The best way to deal with a recurring decimal problem into a fraction is to make sure you get after the decimal point just a recurring number in two different terms. At the moment you can see that x is equal to 0.25, which means just the 5 is recurring. 0.2555 recurring. So this doesn't just have recurring numbers after the decimal point, so I need to times it by 10 to get it to be just recurring numbers. Timesing it by 10 gets me 2.5 recurring, or 2.55555. So that's one of my numbers with just recurring numbers after the decimal. I'm going to then times it by 10 again to get me 100x. And this gets me 25.5 recurring. Taking my 10x from my 100x, I'm going to have 25.5 recurring, take away 2.5 recurring. After the decimal points, all of the recurring 5s cancel each other out. Then I'm left with 25 take away 2 equals my 23. My 100x minus my 10x leaves me 90. Therefore, my original x equals 23 divided by 90. And that is 0.25 recurring as a fraction. Question 15 is a perpendicular lines question.